A phone book with a million names never makes you flip past name number 1 to find name 600,000. Ever wonder why your database can? That's what an index does. The question is how a computer finds one row among millions almost instantly. Let's open it up. Without an index, a database reads every single row, top to bottom, checking each one. That's called a full table scan. Imagine a phone book with no alphabetical order. Names just dumped in whatever order people signed up. Finding Smith means reading the whole book. That's your users table with a million rows and no index on email. Every login checks every single record. Now flip open a real phone book. Names are alphabetized. You know Smith lives near the back, Adams near the front. You skip straight to the S section. You're not reading the whole book. You're using structure to skip work. That structure is the index. It's a second, smaller, sorted copy of one column, pointing back to where the full row actually lives. The phone book doesn't store your job, your car, your medical history. Just your name and an address to find the rest. A database index works the same way. It stores the indexed value and a pointer, not the whole row. So the index itself is small enough to search fast, even when the actual table beneath it is enormous. Under the hood, most databases build this sorted structure as a tree, usually something called a B tree. Picture the phone book split into chapters, A, D, E, H, I, M, and so on. Each chapter splits again into smaller chunks. You don't scan pages. You jump to the right chapter, then the right sub-chunk, then the right page. A few jumps, not 1,000. That's why looking up one row in a table of 10 million can take milliseconds instead of minutes. Postgres, MySQL, SQL Server. Different engines, same trick underneath. A sorted tree that turns linear search into logarithmic search. Here's the number that matters. A table with 1 million rows might need only 20 comparisons to find one row with an index. Without the index, up to 1 million comparisons, worst case. That's the gap between instant and unusable. But nothing is free. The phone book doesn't reprint itself every time someone gets a new phone number. Your database does something like that every single write. Insert a row, and the index has to update too. More indexes mean faster reads, but slower writes. Every insert, update, or delete has to touch every index on that table. A table with 10 indexes on it is a table paying 10 small taxes on every single write. So here's the real skill. Not adding indexes everywhere. Adding them exactly where lookups happen most. Think about how you'd actually use a phone book. You search by name, almost never by phone number. So the book is sorted by name, not number. If you indexed the wrong column, you'd be back to reading every page. That's exactly what happens when a query filters on a column with no index. The database quietly does a full scan anyway. Now, what if you search by two things at once? Last name and city. That's a composite index. It's like a phone book sorted first by city, then by last name inside each city. Order matters here. Search by city alone, and it's fast. Search by last name alone, skipping city, and that same index barely helps at all. This is the part engineers get wrong constantly. They build the index, then filter in and order the index was never built for. One real case. Adding a single index to a slow query at a mid-sized company cut a report from 40 seconds to under one. No new hardware, no rewritten code. Just telling the database exactly how to skip to the right page. So back to the phone book sitting on the shelf. It never stored your whole life. It stored a name, sorted, and a pointer. That's all an index has ever been. A smaller, sorted map pointing at the real thing, so nobody has to read the whole book.